We're going to start in chapter 7, which is about the metric system. And the first section we're going to go through is 7.1, which is about basic terms and conversions. Purely within the metric system. And then we'll talk about converting just in a general sense. We'll deal with the US system that we're used to, but more commonly the metric system is going to be used throughout the world. So if you're taking any science class, you're always measuring stuff in terms of the metric system, not so much in terms of our normal notation of feet, pounds, that kind of stuff. So we're going to start with our basic terms. And we have 3 of them. The meter, which is denoted just with an M, is used to measure length. The gram, which is denoted with a G, is used to measure mass. And the liter, which is denoted with a capital L or a lowercase l, you might see either one, is used to measure volume. So these are 3 basic units for standard stuff that we're used to. We're used to dealing with feet, pounds. We have our gallons terms in terms of milk and everything. There is one more unit too that's specific to the metric system, which is for temperature. So we use degrees Fahrenheit in the US, but pretty much everywhere uses degrees Celsius. So degrees Celsius, which is our degree symbol with a C, is used to measure temperature. Okay. So to give you kind of just some idea with degrees Celsius, because we're used to just normal body temperature, it's hot when it's 80 degrees out. For kind of reference, 0 degrees Celsius is the same thing as 32 degrees Fahrenheit, and this is when water freezes. Okay. Then 23 degrees Celsius is the same thing as 73.4 degrees Fahrenheit, and this is normal room temperature. Okay. 37 degrees Celsius is the same thing as 98.6 degrees Fahrenheit, and that's going to be the average body temperature. And then finally, 100 degrees Celsius is the same thing as 212 degrees Fahrenheit, and this is when water boils. So you can kind of see it's kind of nice. 0 to 100 are those extremes. 0 degrees is when water freezes. 100 degrees is when it boils. So that's common for the metric system. Everything is kind of in powers of 10. So obviously, when we're talking about different things just in general, if I'm talking about the weight of an elephant versus the weight of an ant, I use different units for it because an ant is so tiny that has very minimal weight, but an elephant is gigantic. Same thing with volume. If I'm talking about a glass of water versus the amount of water in the ocean, very different sizes. So we have really a bunch of prefixes that get attached to these 3 units to change kind of that quantity and how big something is. So we're going to go through all of the prefixes that you can attach to those basic symbols. So what I'm going to do is write the prefix itself, what symbol we use in front of that basic unit, and then we're going to put the meaning. So basically, in comparison to that base unit, how large is that quantity? And so in total, we have 7 prefixes, 1 just being the base unit. So I'm going to go ahead and fill in my chart now. I think I don't need that one. Yeah, don't need that. Okay. Put in our separators. Okay. And so right in the middle, we're not going to actually have a prefix or a symbol. This is going to be our basic unit. So that's going to be our meters, our grams, or our liters. Okay. If I go up a step, I would put deca, so decameter, decagram, decaliter. And so in front of that base unit, you put a DA. And basically, this is going to be a larger quantity. It's 10 to the first or 10 times the base unit. Okay. If I go up another step, that's hecto, and that's just abbreviated with an H, so hectometer, hectogram, hectoliter. It's 10 squared or 100 times your base unit. I should be calling this basic, not base. And then finally, the largest prefix we have is kilo. So that's symbolized with a K. It is 10 to the third or 1,000 times your basic unit. Okay. Now, if we want to talk about something smaller, we're going to move down on this chart. So the first one is deci, and that's just going to be a D. So this can be kind of confusing because these are the only two that have similar symbols. But deca is bigger unit, so it's more letters. That's the way I remember it. But it's 10 to the negative 1 or 1/10 the size of your basic unit. Okay. Then we move down to centi, which is a C, so centimeter, which you probably see on most of your rulers. It's 10 to the negative 2 or 1 over 100 times your basic unit. Okay. And then finally is milli, which is just an M. And following that same pattern, it's 10 to the negative 3 or 1/1000th time your basic unit. Okay. If you can remember the order of this chart, really you're going to be able to convert so easily back and forth. So we need to put these in this order to be able to translate back and forth between the two. And then there's a couple phrases that you can use to memorize this. You can look up on the internet some other ones, but the way I remember it is King Henry died by drinking chocolate milk. Okay. And so let me move this to the next page, but I will explain what that means. If you look at that order, King Henry died by for the basic drinking chocolate milk. So it tells you exactly the order these letters appear in. Right? So King Henry died by, that's our basic, drinking chocolate milk. Okay. So if you can remember this order, this is going to tell you exactly how to change units in the metric system. Everything is powers of 10, so you're really just moving the decimal left or right. Let's talk about changing units in the metric system. It honestly makes no difference which of these you're talking about, whether it's meters, grams, or liters. Okay. You put that base prefix in front, so King Henry died by, so this is our base, drinking chocolate milk. Let's go ahead and duplicate this for all of them. And now you just attach the prefix. So meters puts a meter in between everything with the base unit in the middle. Grams puts a G. Liters puts an L. And again, you might see a capital L, completely up to you what you use. I like the lowercase L. So let's start by looking at going from something smaller to larger. Say I want to go from centimeters to hectometers. Okay. What you're going to do is you want to count how many times you have to move down this chart. So I have to move to the left 4 times. What I'm going to do then is move my decimal to the left 4 times. Okay. So to change from smaller to larger, move the decimal point 1 place left. For each larger unit of measure. Oh, that's a terrible measure. There we go. Until we get the desired unit. Okay, so in that example I have in the meters, you go 4 spaces left. Yeah, I can't write today. To go from centimeters to hectometers. Okay, so I move 4 spaces down the chart on the left. If we want to talk about now, let's use green, that sounds good. Going from large to small, if I start at kiloliters and go to milliliters, we do the same thing. We count how many times. So 1, 2, 3, 4, 5, 6. I move 6 spaces to the right. So I move my decimal 6 spaces to the right. So pretty much the exact same thing happens. I'm just going to change a few words. We're going to go from larger to smaller now. So to change from larger to smaller, you move the decimal point 1 place right, because I'm moving to the right on this chart for each smaller unit of measure. So in this example, we would move the decimal 6 places right to go from kiloliters to milliliters. Okay. So let's try some examples. Let's convert the given unit to the indicated one. And so let's start with 6.5 kilometers to meters. So I'm going to start by going ahead and writing my chart down. King Henry died by drinking chocolate milk. And we're using the meters. So put a meter in every spot. We are starting at kilometers and going to meters. So if we count how many spaces, that's 1, 2, 3, and I'm moving right down this list. So we are going to move the decimal 3 places right. So 6.5 kilometers is the same thing as we write the 6.5. The decimal was here. I need to move 1, 2, 3. My new decimal place goes here. Any blank stuff gets filled in with a 0. And then our new unit is meters. So 6.5 kilometers is 6,500 meters. Okay. If we do the same number, 6.5 kilometers, but go to millimeters. I'm going to cheat. I'm going to copy this. I'm still starting at kilometers, but now I'm going all the way down to millimeters. And so counting those spaces, that's 1, 2, 3, 4, 5, 6. So we move the decimal 6 places right. Because we're moving right down this list. So our 6.5 kilometers, we again rewrite the 6 and the 5, and we've got to move the decimal 1, 2, 3, 4, 5, 6 to land here and give us our millimeters unit. So all of these loops get filled in with zeros. This is 6,500,000 millimeters. Try one more of these. We'll do the reverse now. Let's do 40,302 milliliters to decaliters. So I'm going to put my King Henry died by drinking chocolate milk, and we're using liters, so put a liter in every spot. And we are starting at milliliters going to deciliters. So we have to go 1, 2, 3, 4 places, and the direction is left. So we're going to move the decimal 4 places left. So I'm going to rewrite what we have. And I want to put all of these numbers. Okay. My decimal is starting right here, and I want to go 1, 2, 3, 4 to input my decimal right there to give me my deciliters. So 40,302 milliliters is 4.0302 deciliters. Okay. And again, if I had to go, say, to kiloliters, I would go 2 more times. This would move 2 more times to right here. You'd input a 0 in any of those blank spots. Okay. All right, let's try one more example. And we're going to arrange the given quantities in order from smallest to largest. And we've got 1.4 kilograms, 16,300 decigrams, and 1,600 grams. Okay. So part of the problem is I can't compare them right now because they all have different units. So before we can order these, we need to put them in the same unit. You can pick whatever unit you want, but I would recommend pick one of the 3 that's given to you. Don't decide, let's do milligrams and change everything over. You could, but then you have to do 3 things. I have grams, which is my base unit, so let's just put everything in grams. Okay. So I've got to put my units. King Henry died by drinking chocolate milk. And we're dealing with grams. So grams gets attached to all of these. Okay. We will start with transferring over this 1.4 kilograms. So for that one, I'm starting at kilograms and I'm going 1, 2, 3 places to the right. So 1.4 kilograms, we rewrite those digits and I've got to go 1, 2, 3 places to the right. There's my new decimal, fill in some zeros, and 1.4 kilograms is 1,400 grams. So underneath here, I'm going to put that's 1,400 grams. Now our other one is in decigrams. And so I need to go 1 space to the left. So 16,300 decigrams. I rewrite all of my numbers. My current decimal is right here. And I'm going to move it 1 space to the left to right here. And that gives me my unit of grams. So 16,300 decigrams is 1,630 grams. Okay. So checking everything out, this is definitely our smallest. This is the largest gram amount we have, and this one is in the middle. So the order from largest to smallest is 1.4 kilograms, 1,600 grams, and then 16,300 decigrams. Okay. All right, so that is it for our first section. Pretty much today, we're just going to go through chapter 7. I don't think it's too terrible in terms of 3 sections, because this next one is honestly relatively short. It's going to talk about length, area, and volume, but really we're going to dissect conversions even more in the next section. So we're going to talk about length, area, and volume in chapter 8 as well. So we'll get tons of practice with that. So 7.2 is length, area, and volume. Okay. So to kind of just put into perspective these units, 1 kilometer is about 0.6 miles, since we're accustomed to this, and 2.5 centimeters is about 1 inch. Okay. So if we're finding volumes and dealing with this kind of stuff, we need to make sure everything is in the same units. So when we're finding areas and volumes, each side of the figure must be in the same unit. And we'll start kind of nice with shapes we probably already know. We have a square that one side is 1 centimeter, the other side is 1 centimeter. Your area would be 1 times 1, so 1, and our unit is centimeters squared. If I double this side and now make a square with side 2 centimeters and 2 centimeters, the area is 2 centimeters times 2 centimeters, or 4 centimeters squared. So it's really 4 times as large as this other circle, or other square. And that's because you can really fit 4 of those figures in this shape. Make it yellow so you can see a little better. So when we're talking about areas, you have a side times a side. Areas are expressed in square units. So our units squared. If you think of maybe if you've ever like looked at buying a home or you've looked at like lots for something, we talk about acres. You live on a half an acre of property, a quarter of an acre, whatever it is. The metric system also has something similar. So for large areas, the metric system uses a square unit which 100 meters is 1 hectometer on each side. Okay. So you basically have on one side 1 hectometer, the other side 1 hectometer. Its area is 1 hectometer squared. That's called a hectare. Okay. So this unit is a hectare, symbolized by just HA. Okay. So you have your square, make it an actual square. It's got 1 hectometer on this side, 1 hectometer on this side. The area is 1 hectometer squared, which is just 1 hectare. Okay. All right. So let's do one example utilizing this just to kind of see changes in sizes. We want to figure out a square meter is how many times larger than a square centimeter. Okay. So think back to this. A square meter means each side is 1 meter in length. So the area is 1 times 1 meter squared, so 1 meter squared. So 1 meter squared, 1 square meter, is 1 meter times 1 meter. Okay? And I want to really figure out how big is a square centimeter in comparison. So if we think of our conversions, King Henry died by drinking chocolate milk, and we're dealing here with meters, so throw a meter in everything. M. We're starting at meters and going to centimeters. So I have to move the decimal 2 places right, which would give me 100 centimeters. So really for this square meter, 1 meter times 1 meter is 100 centimeters times 100 centimeters. And 100 times 100 is 10,000. And our centimeters times centimeters is centimeters squared. So 1 square meter is 10,000 square centimeters. So ultimately, the area of a square meter is 10,000 times larger than a square centimeter. So your homework is honestly relatively short in this section. It's going to be talking about really just kind of conversions of these units. The other thing that's also interesting is when we talk about volume, we're typically thinking of liters, milliliters, kiloliters, but you can also talk about volume in terms of cubic units. So if I have a cube and each side is 1 meter, then that occupies some space. So we also have conversions between those, okay? So for figures in 2D, we can only find areas. For figures in 3D, which means it has a length, width, and height, we can find its volume. Okay, so in the metric system, volume can be expressed in liters or cubic meters, since both describe occupying space. So to kind of give you a visual, if I have a 3D box, do my best to quick draw a 3D box, you can fill this box with water. You don't want that. You can fill this thing and talk about how much water can be occupied in this box. But more commonly, what you're used to seeing is like in your chemistry class, if that will stop changing to a square and give me a nice ellipse instead, that would be great. There we go. You're used to having some beaker. And then there's some lines on it that tell you how many liters you have filled in that beaker. Okay. So this might have something like meters cubed because this is a meter, a meter, a meter. And this instead would give you liters. Okay. So really we can look at this volume in cubic units. And that gives us a conversion for volume in liters. So if you have 1 centimeter cubed, so a centimeter on each side, that's equivalent to 1 milliliter. 1 decimeter cubed, so a decimeter on each side, would be 1 liter. And 1 meter cubed, so meter on each side, is 1 kiloliter. Okay. All right. So that's really it for this section. You'll have some homework questions. If you feel comfortable with the homework questions, you'll be perfectly fine. Sorry about that. So the last section we go through in chapter 7 is 7.4. It's about dimensional analysis and conversion to and from the metric system. Sorry, hold on. Macy. All right, hopefully she's good. So there are a ton of conversions that are out there between the US system, between the metric system and US system. I don't expect you to memorize all of this kind of stuff. So you'll see a lot of the conversions will pop up on your screen while you're going through your test, while you're going through your homework, and you can also just look something up. The common ones I do anticipate you know, like 1 foot is the same thing as 12 inches. 1 yard is 3 feet. I do not expect that you know 1 mile is 5,280 feet. 1 pound is 16 ounces. 1 ton is 2,000 pounds. 1 cup is 8 fluid ounces. 1 pint is 2 cups. 1 quart is 2 pints. 1 gallon is 4 quarts. Those I don't anticipate you remember, which is why you can see the US system is a little jacked up in comparison to the metric, where you just move decimal places. This is really arbitrary numbers that you have to memorize. The other ones are standard though, like 1 minute is 60 seconds. I expect you know this now. 1 hour is 60 minutes. 1 day is 24 hours. And 1 year is 365 days. This is hopefully stuff that you remember and know. But really, all of these quantities are equivalent. So we can use them to convert between units. Okay. Best thing we can really do is try an example. And then we'll do just really a bunch of conversions after that, answer some questions as well. And that's about it for this section. So we are told a container holds 26 ounces of salt. We want to figure out how many pounds is that. Okay. So the conversion we have is 1 pound is 16 ounces. So what I want to do is I want to start with this 26 ounces. And I basically want to multiply by something that doesn't change the 26 in a sense. Kind of like when you have an equation and you add 5 on both sides, it doesn't change it. You multiply by 5, it doesn't change it. If I take something and multiply by 1, it doesn't change the overall meaning. So my goal here is I want to multiply by 1 to not change anything. And that one we're going to use is exactly this conversion. 1 pound is 16 ounces. So if I put 16 ounces on the bottom, it is equivalent to 1 pound. It does not change my overall meaning. I'm not introducing more of this quantity. But by doing this, I've got ounces in the numerator, ounces in the denominator. It causes this ounces unit to disappear. And so all we're left with then are pounds, and that's what I want to get to. So what we're left with is the 26, the 1 in the numerator, 16 in the denominator, and our unit is now pounds. So if you take 26 and divide it by 16, this tells us 26 ounces is 1.625 pounds. Okay? So this is essentially going to be your goal. You want to multiply by a quantity from one of these conversions so that you don't change the amount of thing there is, you just change the units. Okay? So I just have a ton of examples. Convert to the given unit. If you know a different way to do conversions, absolutely feel free to go about that. So let's do 5,000 pounds to tons. Okay. So I want to take this 5,000 pounds. I want to multiply by some quantity where I have pounds in the bottom and hopefully tons up top. Sometimes you might not get so lucky. But using our conversions, 1 ton is 2,000 pounds. So that causes my pounds to disappear. I'm left with a 5,000 and a 1 in the numerator, and 2,000 is in the bottom, and my remaining unit is tons. So 5,000 divided by 2,000 gives us 2.5 tons. Okay. If I want to do 15 quarts to cups, if I go back to my chart, unfortunately, if I start at quarts, I only know how to convert to pints. But then from pints, I can convert to cups. So we're going to use those two quantities. We'll start with our 15 quarts. And the first equivalent quantity I know is that 1 quart is 2 pints. So that gets rid of the quarts unit, but it leaves me with pints, not cups. So I got to multiply by something else again with pints in the bottom to make this pint unit disappear. And 1 pint is equivalent to 2 cups. So now my only unit left is cups. So I've got a 15, a 2, and a 2 up top, and just a 1 and a 1 in the bottom with cups as my unit. So doing that multiplication, 15 quarts is equivalent to 60 cups. Okay. Next one's a little bit harder. We want to convert 60 miles per hour to miles per minute. So this is really a rate. We're going 60 miles per hour. So that's telling us we're going 60 miles in 1 hour. So this quantity is given by this fraction, miles per hour. I don't want to change the miles unit. What I actually want to change is this hours unit to minute. Okay. So I want to get rid of hours, which tells me I need to put hours up here to cancel it out. And I want to get miles per minute, so that really means I want minutes in the bottom. And 1 hour is equivalent to 60 minutes. So by putting these in this location, get a color that's easier to see, getting rid of the hours, we're left with a 60 and a 1 up top, a 1 and a 60 in the bottom, and the unit in the numerator is miles. Now the unit in the denominator is minutes. So this ends up being 1 mile per minute. Okay, that's what this unit means, miles per minute. and then 60 over 60 is 1. Okay. We'll try another one of these rates. We'll still work with the 60 miles per hour. And we're going to convert it to feet per second. And so this one's definitely harder because I have to convert both these units. I've got 60 miles per 1 hour. I want to convert to feet and I want to convert to seconds. So let's start with getting to seconds because that one's going to be kind of more similar to the last one. I need to get rid of this hour unit. So that means I need to put hours up top. But the only conversion in my head I know is 1 hour is 60 minutes. Okay. But minutes is still not the unit I want. So I need to multiply again by something with minutes in the numerator to go ahead and make these cancel. And the conversion I know is 1 minute is 60 seconds. Okay. And now I'm okay. Per second, I've got seconds in the bottom, so that's good. But now I need to work on changing over this miles unit. And we want to get to feet, but miles is in the top, so I need miles to go in the bottom to make these cancel. And the conversion I know is 1 mile is 5,280 feet. So my only units left then are feet and seconds, so feet per second. So all of these units cancel. We get the 60, the 1, the 5,280 in the numerator. 1, 60, 60, and 1 in the denominator. And our unit is feet divided by seconds. So really those ones make no difference. You don't need to really write them every time. Just pick the most important ones that stay. And so if you do this multiplication and division, you should get 88 feet per second. Okay. All right, so we are almost done. Now let's work a little with the US and the metric system. So to convert between the US and metric system, you're going to see your chart on page 423 in your textbook. You can Google it too. Your homework should have a lot of the conversions in there. These are not anything you need to memorize. I'm really just going to give you the unit in here, or that conversion in here. And so the first one is 12 pounds to kilograms. And the conversion in our book tells us 0.45 kilograms is equivalent to 1 pound. So I'm starting with 12 pounds. I want to multiply by a fraction that gets rid of pounds. So it goes in the bottom, which means kilograms goes in the top. So this will make the pounds unit cancel. And I know 1 pound is 0.45 kilograms. So that really just leaves us with the 12 times the 0.45. The 1 in the bottom does nothing. Kilograms. So that's 5.4 kilograms when you multiply that out. If I do a second one, let's do 90 inches to centimeters. And our conversion is 2.54 centimeters is equal to 1 inch. So I'm starting with inches, which means in our fraction, inches goes in the bottom, centimeters goes in the top. And this will cause the inches to cancel. Filling in our blanks, 1 inch is 2.54 centimeters. So this is really 90 times 2.54 centimeters, which is 228.6 centimeters. Okay. And now to kind of piggyback off this one, we're going to do 765 millimeters to inches. And this time I still only know this conversion. 2.54 centimeters is 1 inch. Okay. So since we don't have a conversion from millimeters to inches directly, let's first convert millimeters to centimeters. Okay. So I've got King Henry died by drinking chocolate milk, dealing with the meters unit. We are starting at millimeters, going to centimeters, which means we are going one space to the left. I can make a nice arrow. Okay. So 765 millimeters is equivalent to moving that decimal 1 to the left, which is right here, centimeters. So 765 millimeters is 76.5 centimeters. And now we can convert centimeters to inches. So 765 millimeters is equivalent to 765 centimeters. And using our lovely conversion, we know something between centimeters and inches. 1 inch is 2.65 centimeters, or 64 centimeters. 2.54, man, can't read. So this makes our centimeters unit disappear. We're left with 76.5, 2.54 on the bottom. And our only unit left is inches. So roughly this is about 30.1 inches. So the last thing we're going to do is what happens if you have area and volume. You can look on that same page to kind of see conversions between the two, but I'm going to show you a different way instead. And I'll show you using this as well. So when converting area or volume, there are some conversions on page 423 to help us. So you can look in your textbook for that. 1 foot cubed is 0.03 meters cubed. 1 inch squared is 6.5 centimeters squared. And that list really just goes on and on. But really, I think the easier thing to recognize is that inch squared is inch times inch. Feet cubed is feet times feet times feet. So you can go through that route, or we can recognize we have 2 or 3 conversions to make. I'm going to show you with an example both of these processes. You can pick whichever one you want. Suppose Victoria is buying an outdoor carpet which needs to be 6 yards by 9 yards. The carpeting is only sold in square meters. How many square meters does she need? So to give you a visual, here's our carpet we need. This side is 9 yards. This side is 6 yards. The area is 9 yards times 6 yards, or 54 yards squared, which we need to convert to meters squared. So I'm going to show you one method. you'll see we get the same thing really, maybe off by like slight decimal just because of the conversion rates. Oh. But this is going to use the fact that 1 yard is about 0.9 meters. And so I want to do 9 yards times 6 yards. I need to get rid of both of these yard units. So I'm going to multiply by a fraction, get rid of one of the yards with meters by saying 1 yard is 0.9 meters. That will make this one disappear. But I really got to do it again to make this other one disappear. So this yards will cancel with this one. But again, I'm going to put the same conversion rate. Okay. So what that gives us then is a 9, a 6, a 0.9, a 0.9, and our units are meters times meters. So if you do that multiplication out, it's 43.74 meters squared. So that's how much carpet she would need in meters squared. The second method is going to use that chart on the other page, which tells you 1 yard squared is 0.8 meters squared. Okay. And so this is from the chart on page 423, which again is not perfect because if I take 0.9 times 0.9, it's 0.81 meters squared. So these conversions can be a little bit off. And so what I'm going to do now is she needs a total of 9 yards times 6 yards, which is 54 yards squared of carpet. And now using this conversion, 54 yards squared, we go ahead and multiply using our conversion rate. 1 yard squared is 0.8 meters squared. So the yards unit cancels, and you get 54 times 0.8 meters squared, which is 43.2 meters squared. So you can see they're a tiny bit off, but again, that's just because we don't have perfect conversion rate. 1 yard squared is not exactly 0.8 meters squared. So either method, perfectly fine. You can decide which you want to use. I think this is the more common of the two, just because you're not going to memorize these square conversion rates. But if you want to go ahead and utilize that chart to your advantage while you're doing homework, absolutely.